finding the derivative and inverse at a point, like we do one of those problems?
Sure.
All right, thank you.
Okay, let's look at this one here. Okay. Thomas, do you need a sheet of paper? Just like I was just taking problems for the textbook.
Okay, I'll give you a notebook.
Okay, so let me highlight the steps and then have you guys try it. Okay. If I want to find the derivative of inverse at a point, I have to recognize that first step is that the number given to you is not the x value, it's the y value. So the first thing you want to do is you want to find the x value.
Wait, what?
You see this number right here?
Mm-hmm.
This is not the x value, that's the y value.
Okay.
So how can I use this to solve for x?
Keep it to the other side.
Yep. So what would that look like?
So the y value is 2, so would you make f of x equals 2?
Yep. Let's bring everything over to one side. So the issue that you're going to run into is that this equation is not factorable. We're not going to be able to go through the quadratic formula. The degree is off, right? It should be x squared, but it's x cubed. So we're going to have to go through a series of guess and check. Okay, but the number will be easy to find. It'll be numbers either 0 or numbers around 0.
Would this be 1, right?
Okay, let's try 1. 1 cubed plus 2 minus 3 is 0. Good, so we have our x value, right? Next step is we want to find the derivative of this function.
Will be 3x squared or plus 2.
So now we have a slope formula for the function. How can we use this value now to find our slope?
Should we make the other side equal to 0?
How can this x value help though?
We plug it in.
Mm-hmm.
And then what we get is the slope. Is the answer we get the slope?
Something related to that. Let's find f prime of 1.
So it's a equals 5.
Yeah, so we have our slope on the function, which is fine. I want to give you a visual reminder as to where we are in our problem. So this is what we've achieved. We're basically, let's say this is the function we're working with, right? We found the x value, we found the derivative, we found the slope, and that slope is 5. But this is actually not the slope we're looking for. We're looking for the slope of the inverse at its corresponding point, and that's going to be in a different location. So on the inverse side of things, the x value is 2, but our x value is 1, so everything's kind of flip-flopped, right? So on the inverse side of things, the slope is not going to be 5, but it's going to be what?
1/5.
Right, so the derivative of the inverse at the corresponding point is the reciprocal of that slope. So because this is 7, we know that the slope of the inverse is going to be 1/7. So for our problem, if our slope is 5, we know the slope of the inverse is going to be 1/5, right? You see how they're both positive slopes, but one is steeper than the other. So we don't want to change the sign. We're just going to flip it. Okay, Joey, does that help?
Yeah, that definitely helps. Thank you.
Can we talk about the first one on the like the all topics? Can we talk about the first one? The one where it says given a function f of x, find relative min, max,
Okay,
and the whole
yeah,
thing.
we can do that. Let me find one to do. Okay, so this, we're going to find relative max and min. So let's start off by finding the derivative. If I want to find relative max, relative min, I had to find f prime. To find f prime, what do we have to involve here? How do you find the derivative of that?
That would be quotient rule.
Would it be 1/x?
Not quite. These are two separate functions. We got to go through quotient rule. Yeah. Okay. So go ahead and see if you can fill those in, and then we can go over it. You got it already?
Would it be ln(x) minus 1 over ln(x) squared? Or do we have to put like the dx or dy? If possible. This one is. This one.
Good.
So this.
That's it. Yeah. And now 5 critical points. So set that. Set the top and bottom equal to 0. Separately.
Wait, so how do you do critical points?
Set the numerator and denominator equal to 0 separately. Yeah.
Okay. I don't know how to do that.
Okay, I'll go over it with you. Okay, did you guys get this far here?
Yeah.
Okay. Joey, Nolan, you guys good?
Yeah, I'm good.
Okay.
Okay.
So we want to find relative extrema, but we have to look for critical points. So critical points, we set the numerator and denominator equal to 0 separately. So let's get these equal to each other first. Okay, so natural log of x equals 1. All right, we're trying to solve for x, right? How do we get inside that x when there's natural log involved?
Isn't natural log of e equal 1?
Something like that.
Oh, you can but you can put them both to the power of e. Right?
Yeah.
Or
So
E.
what's the inverse function of natural log?
Is it 1 over?
It's going to be e
e ln e to
e
the
to
power.
the x. So exponential function and natural log, they're inverses of each other. So if I can pair natural log with its inverse, we can find a way to kind of make them cancel each other out. So I'm going to raise both sides with e as the base. And if I pair e and natural log together, they're going to help each other reduce. So this side is going to clean out to be just what?
1.
X. So e and natural log cancel out. The only thing left over is whatever's inside of natural log.
Should I make x equal e?
X equals e, yeah. Okay, let's do the same thing on the denominator side of things. I can take the square root to get rid of that 2.
Can we do the same thing? And then
Same thing, yeah.
so e to the 1 1. Would be x squared equals.
If I take the square root of both sides, I can get rid of that exponent. So I'm just left with natural log of x equals 0.
Yeah, x equals 0.
Close, something though,
Oh,
right? Anything to the 0 power is
1.
1. So here's our f prime sign line. So we have e and we have 1 that goes on the sign line. There's another number that's going to go on the sign line. Do you know what it is?
0.
Because
The starting point is 0.
it's the starting point, right?
How do you know that though from looking at the
How do we know that? Okay, so we know that natural log by itself already has this restriction, right? So
Oh,
if there's a restriction with only one part of the problem, it's going to extend for the entire problem.
okay.
If I can't have -1 that exists as part of the problem, it's not going to exist anywhere on for the overall value. So any one little restriction is going to kind of carry through the entire problem. So natural log of x has a domain from 0 to infinity, so that's going to carry over to our full function as well. Okay, what do we do from here?
Find if it's negative or positive.
Test numbers, right, against our f prime. I'll choose 1/2. I'll choose 2. I'll choose e squared. Okay. Plug into our derivative function. So natural log of 1/2, that's around 0.5 or -0.5. Negative minus negative is negative. What's nice about the denominator? Right, so it's negative or positive, which is negative, right? Okay, natural log of 2. Natural log of 2 is somewhere here, and that's looks like it's around 0.5. So 0.5 minus 1 is still negative, so negative or positive is still negative. And what about?
How about like, so do we need to know like that graph for E, or do we? Like,
You can just enter in the calculator.
Oh, you can.
Mm-hmm. Yeah. Okay. Natural log of e squared minus 1. This is the same thing as what?
2.7 times 2.7.
So let's even easier. Where can I put that 2? That 2 can come down in front. Right. So what's natural log of e?
It's 1.
This is 1. Yeah. So 2 minus 1 is 1. 1 over positive is positive.
You didn't square the bottom one. We're using e squared, right? But on the bottom equation, you just made e.
Oh, sorry. Yeah. Yeah, you're right. So what can we conclude? Any relative extrema?
Would E be a relative min?
Mm-hmm. And how would I find the y value?
Plug it in the first equation.
Yeah, first equation. So e over natural log of e. Natural log of e is 1, so relative min is going to be at e, comma e. Okay, so we have f prime. Let's move on to f double prime. So if I want to find the second derivative, what do we have to involve here?
We make f of x equals 0.
If I want to find the second derivative, though,
Oh.
what do we use from f of x to f prime?
Quotient rule?
Yeah, quotient rule here, right? Numerator, denominator. But there's a little bit of chain rule because of that denominator squared. All right, try that.
What's the derivative of Ln?
Derivative of natural log.
Yeah, natural log x will be a derivative.
Yeah, it's u prime over u. Okay, what'd you guys get for f prime?
One over x.
Mm-hmm. G function, the same, right? Minus. Now G prime, you see how we have a parentheses with exponent outside? We got to do chain rule here. So there's an outside portion and there's an inside portion. What's outside's derivative?
Would you just move 2 down to the front, and since the exponent's 1, would you not have to like put it around the parentheses?
Yeah, you can just leave it like that.
Okay.
Inside stays the same. Times the inside's derivative.
Would it be 1 over x again?
Good. All over.
ln x to the fourth.
Mm-hmm. All right, this looks like a mess, right? We have to look for critical points now. So we're going to set the top and bottom equal to 0, but let's do a little bit of cleanup before we look for critical points. So to speed this process up, I want you guys to think of these as two separate expressions up top. You see how all these are being multiplied together? There's a minus sign, and then you have all these terms being multiplied together. So what if we treat these like two separate expressions, and we just pulled out what is shared, what's common between those two? So what's the common factor that you see between this and this? Okay, what else? 1 over x. What if we take both of them out? Okay. So just like how we would do common factors, right? Once we pull the common factor out, the leftovers remains inside, right? So if I take a 1 over x natural log of x out, what's left from here?
1 minus 1 squared? Or 1 times 1 squared, sorry.
1 times. Let's just look at the first expression here.
Okay.
If I take out a 1 over x natural log of x, what am I left with? What does that natural log of x squared mean? That means this natural log of x and another natural log of x, right? So if I remove one natural log of x, what am I left with still? Still natural log of x. Does that make sense, Thomas? Okay, so what about here? If I take 1 over x and natural log of x out, what am I left with? I'm going to remove a 1 over x and natural log of x.
2 times ln x minus 1.
So this is out, this is gone, but
Oh, yeah, I guess you could.
I'm left with this and this, right? I can't take away this natural log of
Actually,
x.
I thought the 2 is like spit square.
Oh, okay. So these two are gone, right? But we're left with this and this.
Mhm.
I'm going to put the 2 in front to make it easier for me to distribute later on. The nice thing about multiplication is that I kind of rearranged it in however way is easy. All over denominator to the 4th. You see how the numerator cleans up a lot nicer now? We can find common factors. We can clean this up a lot quicker. And now you see that natural log of x? That is now free to cancel with this denominator. Before we couldn't just cancel them out, but now that the factor is out, we can take one of them out. Okay, clean up the numerator here. This becomes natural log of x minus 2 natural log of x plus 2. The x can come down and share the same space as this natural log of x. Combine some like terms there. Okay, there's my f double prime. Okay, any questions there?
I was a bit confused at the beginning part, but I think I understood like how you got some derivatives for some of the functions, like how you got 1 for f prime and stuff.
Mm-hmm.
I was a bit confused on that, but I think I understood that.
Okay.
Looking at that.
Good. Okay. All right, so we got to find critical points here as well, right? So set the top equal to 0 and set the bottom equal to 0. See if we can find those critical values. Okay, so just like how we did f prime, see if we can find those critical points.
What is e lmx to the e or e to the lmx equal to?
E to the
X.
ln of x is equal to x.
Okay. So e2.
Mm-hmm. So what would your x equal to? Not quite. How do we do this
No,
problem?
wait, no, e to 2 is.
Yeah, leave it like that. It's just e squared.
Yeah, e squared. So I
That's-
need to calculate that.
It's like 2.7 squared, which is like maybe close to somewhere between 8 and 9.
Yeah.
Okay, so how do we find our other critical points? Where do we look now? Denominator, right? Just like f prime. You get x equals 1. Okay, so f double prime, here's our sign line. We're going to choose values and put it into the second derivative function. So I'll choose 1/2, I'll choose e, and I'll choose e cubed, because those are values that will work out nicely and quickly without having to go through a calculator.
Would be negative element 0.5.
So natural log of 0.5 is going to be a negative number. So negative times negative is positive, so positive plus positive. So that's positive. Now natural log of 1/2 is still negative in the bottom. Negative cubed is still negative, so positive over negative is, sorry, negative over, positive over negative is negative, right? So concave down. Okay, what happens when I plug E in? Natural log of E, that's 1, negative 1 plus 2, that's positive, over a positive, so that's going to be
How do you
positive.
find natural log?
Hmm?
How do you find natural log or something?
You can just enter in the calculator. So in my calculator here, if I do natural log of E, it'll be 1, right? Natural log of 5. Okay, E squared. Sorry, E cubed. Is what you were asking, Thomas, about how to plug E cubed in. So this looks like a difficult thing to do, but you see how we have exponent properties that we can apply? We can bring that 3 down in front. And we really don't really care about the whole value. We just want to know whether it's positive or negative or negative. Okay. What does this reduce to be here?
Negative 3.
Yeah, natural log of E is just 1, right? So negative 3 plus 2 is negative. And then denominator, E cubed, natural log of E cubed, all that's going to be positive, right? These are all positive. So negative or positive is negative. So we can make a conclusion about E squared. What's happening at E squared? Based off of the sign line here. There's something about, what does that tell us here? This is what, concave followed by, yeah, what's that transition point called?
Point of influence.
Yeah, point of inflection.
Oh, my bad.
So we know this is point of inflection, right? There's a change in concavity. So if the graph looks like this, we're basically we're able to find that transition point, right? That point of inflection there. Okay. There's change in sign here, but we know 1 is a place where there's a vertical asymptote there. So there's only a point of inflection at E squared. Yeah.
Wait, how do you know there's a vertical asymptote at 1?
That's just something that we gathered from the original problem here. Natural log of 1 makes the denominator 0, and anything that makes the denominator 0 is a vertical asymptote. Yeah, so point of inflection at E squared.
Can you go over like how you got the F prime G prime to make sure I got it, like the right idea of how you did that implement that I currently have in my head
Okay.
at the beginning? Because I have an idea of how you got it in 1 and whatever I figured maybe that would be the way.
Okay, so you're good with F prime. Oh, sorry, F prime. X becomes 1, right? X, now, natural log of X, the rule that we're using is this right here, is U prime over U.
Right.
So my U value is X. So X's derivative is 1. So 1 over u, so 1 over x.
Okay.
Yeah.
Okay, then I'm right.
Mhm, Good.
I was just making sure based on, like, I had a feeling it was derivative related, but I just wanted to make sure.
Mhm. Good. Okay. What else you guys want to do? Do you want to do a log differentiation problem? Do you want to do a derivative rule problem?
Let me look at the sheet real quick. I gotta see what we need.
Yeah, so here's the
Yeah, can we do log differentiation
log differentiation. Okay.
and plus? Not very sure. Nice.
Okay, let's do this one here. X squared plus 4x raised to the 5 over x. Find the derivative. Okay, what's strange about this problem?
It's to the power of 5 over x.
Okay, and what's odd about that?
Usually it's a whole number.
Well, I mean, it could be a fraction, right? If we see a fraction, it's not an issue. Like this 5/3, it's okay.
Right, because there's a variable in there.
There's a variable, right? So there's a variable below, there's a variable above. This is an issue, right? We can't do chain rule, we can't do power rule, we can't do exponential rule. So we don't have a rule for this. Okay, so what can we do so that we can maybe have this in a different form?
Oh, Ellen, change it to natural log y.
Yeah. So if we introduce natural log into this problem, then this 5 over x can be put in a different location, right? We can use power property. Okay, so this is a log differentiation problem here. So take the natural log of both sides. And now, how can we rewrite this problem so that we're not having to deal with a variable raised to a variable?
Natural log y equals 5x natural log of x squared plus 4x.
Okay, Thomas, any questions here? Okay, what's next?
We find the derivative now.
Derivative, okay. What's involved here?
Y. So it's dy dx.
Yeah, implicit. Okay, what else? Something on
Is
the
there
right
any-
side here.
Is there any is it chain rule? It's not chain rule, is it?
A little bit, but there's a larger rule I want us to recognize.
Can we just move all this to the numerator?
Say it again.
Can we move like the whole equation to the numerator that one?
Make it all. We could make it a whole quotient rule. I would prefer not. feel like that could make things more complicated.
Product rule?
Yeah, I know that x is in the denominator, but we're going to force it into a product rule. How would you rewrite this 5 over x so that we can make it into a product rule?
1/5 x times x. I mean, or 5 times 1 over x.
We could.
That would make more sense.
5 times 1 over x.
Close.
1 over x times 5 ln.
How about this? How about we bring the x up? That's what I was thinking here. So yes, you could make this to a quotient rule. You can make it 5 natural log of x squared plus 4x all over x, go through quotient rule.
I was talking about like this 5 over x. But I thought that's what you were talking about.
Oh, doing quotient rule here?
Yeah, that's what.
Yeah, we could do quotient rule there, but it's going to be a lot cleaner or a lot faster if I just make it into a power rule, right? Okay, so now we're ready for our derivative, right? What does natural log of y turn into?
Dy to the dx. Dy over dx.
Something in front though. There's a u prime over u.
No. It's not. It's going to be 1 over y.
Yeah. Okay, what's f prime going to be?
Negative 5 to the negative. No, negative 5x to the negative 2.
Good. And then g prime is u prime over u. Okay, it's a really messy right side, but we can leave all that kind of just, we can leave all that messiness there. So our final, what's our next step? What's our goal? What are we trying to do?
Find the derivative.
Yeah. So you want that dy dx by itself, right?
Yeah. So divide the whole thing by y.
Divide the whole thing by 1 over y, which is anything
And
else.
multiply the whole thing by y.
By y, okay. So basically move the y over to the right side.
Do we have to like simplify the equation?
No, you don't. It's just a habit for me to look for ways to clean up if I can, but you don't have to. Okay, what's the final thing we do here? I've got a better thing than y here. What can I put instead of y?
ln y? I don't know.
What's y equal to?
Oh, x squared plus 4x.
Yeah. So like I said, it's going to be a really messy derivative, but it's okay.
Where'd the y go?
We replace the y in terms of x. So what's y equal to?
Is equal to x squared plus. Oh.
Just make a clean substitution, right? we started with a function, so we should be able to represent our derivative without having to deal with y. So y is kind of like a, it's like a placeholder until we're ready to represent our answer purely in terms of x. Okay. Okay, so if you have any more questions, I'll be available 7:30 tomorrow morning. If you want to come in the morning or lunch, 5th period, or after school. All right. Take care. See you, Nolan.
Bye. Thank you.
Bye.